Hello everyone, before we start the video, make sure to subscribe, hit the like button, and then we'll get started. Today we're going to take a look at Next.js. I should make a quick note that to really understand what's going on here, you need to have a pretty solid grasp of React itself. Why do we even need Next.js? When we're in the early stages of developing our application, we might not think about how we'll later optimize our site for SEO, just general optimization, performance, and so on. We start writing our own implementations, which often aren't very good. Next.js can protect us from these problems right from the start, straight out of the box. What is Next.js? First of all, Next.js has a more convenient routing system. With Next.js, we already have a ready-made structure that we simply expand. That is, there's a pages folder where we'll write our files. Depending on the file, certain URLs will be set up for us on the page. Now, Next.js version 13 has been released. The API has changed a bit there. Now we have an app folder. We'll go over all of this as well. Routing works a bit differently there now. Next, rendering. There are several types of rendering. We can see them on the screen right now. A bit later, we'll look at each one separately and discuss why and when each is needed. File optimization. That is, in addition to optimizing the JS bundles themselves, we also optimize CSS and images. In other words, we can set up loaders and load them depending on whether we need them on the screen or not. So all of this is very convenient. All of this is really cool. The same goes for fonts. All of this has a very positive effect on our overall performance. We can also create a small API. That is, we have the option to create an API directory inside the pages folder and set up some of our own endpoints there, for example, to interact with something like Prisma. So this is also implemented in a very convenient way. Now let's move on to rendering. Why are there 4 types and why do we even need them? The main one, which is basically used everywhere, is client-side rendering. What's the issue with it? When we deliver our index.html to the client, we can open the element code and see that there's only one div in the code. So we have a single div with the ID root, and that's not really great for SEO optimization. So in most cases, it's basically unclear how we can even optimize this because search engine bots can't see what's on the page and as a result can't index it. To solve this, we need to make sure that the content is already present on the page. How can we do that? By using server-side rendering. Server-side rendering is designed so that we render everything on the server side and then deliver it directly to the client. So the client already sees a fully rendered layout. If you open the element code, you'll see all our data and all our divs right there. In other words, it will also be rendered. Accordingly, search engine bots will index everything without any problems. I should add a small remark here. Nowadays, search engine bots have actually learned to work with this kind of front end. So even when we have just a single div, search bots generally index such frontends as well. Next, the difference between client-side and server-side rendering is that with client-side rendering, we receive a minimal response quite quickly. That is, we get something right away, but the user will see some loaders or some content loading in, so it's not a fully ready situation. With the server-side rendering, it's a different story. We wait a bit longer for the server's response, but we already see, roughly speaking, a fully prepared page. In other words, we don't see any loaders or loading animations. It's also worth mentioning that server-side rendering is quite resource-intensive for the server itself, so you need to consider your server's capabilities. Next is static rendering. Static rendering differs from server-side and client-side rendering in that with client-side rendering, we always connect some kind of dynamic content, for example, loading posts or records every time we refresh the page. With server-side rendering, it's the same thing, except everything is done on the server. Static rendering, on the other hand, is different in that we generate our HTML files statically. In other words, roughly speaking, static content is the easiest to render because we're not working with any dynamic data. We don't fetch, we don't render, and we don't modify anything. Incremental rendering differs from static, server-side, and client-side rendering in that, for example, our posts that users add dynamically will be automatically loaded incrementally. Let's start getting familiar with the code. As soon as we generate the project, we'll have a pages directory. It's clear that the public folder is where we'll keep assets like images and so on. Pages is our main directory where our pages are located. That is, it handles routing. Next, we have modules, which is self-explanatory. Next is the folder where our finished build is stored. Let's move on to the main folder, pages. In pages, we already have a ready-made routing structure. Now let's start the project with npm run dev. The project is running on port 3000. Let's take a look. So let's say we have hello. If we change the name to posts, for example, we change the name to posts. Now we have a 404 error. No problem. We specify posts and see that it also renders. So depending on the file name or the directory name, routing will occur. We need to clarify one point. In our pages directory, we have two files, app tsx and document tsx. App tsx is our main layout, the main component that wraps all our pages. Here we can attach our editor and pass props as needed. As for document tsx, it's needed so that we can modify our structure. For example, let's say we want our scripts to be loaded before our main, that is our data. If we open the code to take a look right now, we'll see the situation. So elements, we'll see that first the scripts are loaded and then we have hello. If we switch it back, we'll see that first there's a div and only then the scripts. In other words, this file is needed so that we can modify the DOM structure. Let's basically start developing our application. We'll create a small application that will display posts. And where do we start? We'll start by creating a folder called posts. We'll move the post tsx file over into the new location and rename it to index tsx, because our routing will be based on the URL posts, index tsx. We will use the JSON placeholder service. To start, let's write our page, call the main function, return a div with an home saying posts. Next, we'll write a div. We will need posts. Let's write a service to fetch posts. That is, we'll move all of this into separate logic, write a service, and create an index.ts file. Here, we'll write our constants, const URL. Let's write the path to our JSON placeholder. Next, we write our service for interacting with and fetching posts.ts. Let's import the API URL. Next, we'll write the interface for posts. We'll have user ID as a number, ID as a number, title as a string, and body will also be a string. Next, we'll write the function to fetch all posts. The function will be getAllPost. So we don't have any input parameters. The output parameter here will actually be a promise of posts. All right, now at this point, we'll make a request response await here. Here we make a request to our API URL at posts goods. Now we get our data, const data equals await response. JSON, actually we can even do it like this, return. That's how it works. All right. Next we have fetching a single post. We need to fetch one post and display it. Async function get one. So we need to get the ID in order to fetch this post. And we also get a promise, but this time for a single post. All right, now let's write the following line of code. Const response equals await fetch API URL posts. This line sends a request to the posts endpoint defined by API URL and waits for the server to respond before moving on. And here we'll specify the ID of the particular post. Next, return response. Got it. All right. We've written our services for interacting with JSON placeholder, so we can fetch all posts, fetch a single post, and we can already interact with it. Let's say we fetch all our posts. Now we'll write the code to fetch our posts. So for example, const posts, set posts equals use state. Let's type our state. Here we'll have the posts. Next, we'll set an empty array. All right. Let's write use effect. And we'll call our service, get all posts, then data. And we'll pass our data to set posts goods. Now we have the posts. For example, we can display them. We use posts map for each item, render a div with the item. Let's say the title. All right, we refresh and go in. All right, the posts are displayed. Now, if we try to open the element code, the page source, and break the lines, we see that basically our code is empty. That is, we're not rendering anything. There is no data here. Accordingly, search engine bots can't index these pages in any way. Well, nowadays, of course, it's a bit easier with all this, but still, we're not displaying any data. How do we display this data? It's very simple. And next, we have the functions get server-side props for SSR and get static props. We also have get initial props, which is from an older version. Get initial props used to work when we first entered the page. Now, there are some problematic issues with navigating between pages. If we navigate between pages, sometimes the request can hang or not execute properly. That's why it's best to use get server-side props now. It's used for fetching data. We write our function, export async function, get server-side props. Next, const posts. We move our logic here. Await. And we are already returning our props. Return. We return an object. We have a props field where we specify our props. This prop will be posts. We also need to accept these props. So we need to accept posts, and we'll also type our props, meaning we'll define a props interface type. Let's write posts here and specify that it will be of type post. All right, now let's specify it here and remove all of this. Let's refresh our page. We see that everything is still working as before. Let's look at the page's code. And if we break the lines, we can see all our data. So everything is already rendered on our page. But how does this happen? When we go to the page, the server sends us our ready-made markup. That is, everything comes to the client already prepared. If this were client-side rendering, when we accessed our client, there would be a moment when we receive the index HTML, index.js, and all those files. Then the rendering would happen on the client side. That is, all these elements would be drawn, as we saw earlier. So we just had a single div, and that was it, let's say. In addition to passing props, we also need to filter somehow. We can add an input that allows us to filter in some way. So we'll write const filter data, set filter data in the state. This will just be our search field. Here we'll have a string, it will be a text string. Next, we need to have a handler, const change filter data. This will be an arrow function that takes an event, which is of type React change event, for an HTML input element. All right, and now here we can set our filter data to event target value. Now we need to actually write our input. Let's add a placeholder here, searchand. For the value, we'll use our filter data, and for onChange filter data as well. All right, and now we need to somehow wait. There's an error. Let's create the filter. This is our item. We can immediately destructure it to get the title. Let's go ahead and compare. We'll check if the title includes filter data. Great. Now let's save it. Let's go back to our page. We see the search. Let's try typing quiz essay, and we can see that our search is working just as it should. Good. Now we've just worked through our server-side rendering. When we go to the client receives an already rendered page. Now let's look at static generation and how it works. To do this, we'll set up fetching a single post by creating a file to get our dynamic parameters from the URL. For that, we need to use square brackets. Inside these square brackets, we write the identifier that we'll use. Let's write tsx, and here we'll fetch our single post. And in order to fetch it, we need to let's write our export as a default functional post. Next, we'll write return div here. All right. Now we need to somehow get our ID from the route. To do this, we need to import the useRouter hook, the hook from Next. With this hook, we can get all the parameters we need that are related to URLs. We declare a const destructure query from useRouter, and now we can display the ID here in the div query ID. Let's save it, and now let's see how it looks. We have our post. Let's enter, say, 1, go to it, and we see ID 1. So we can retrieve our ID. Now we're going to get acquainted with another function of ours, getStaticProps. Let's write its export as an async function, getStaticProps. The first parameter we have is context. Context is exactly where we call this getStaticProps. And with the help of our context, we're now going to get our specific post. We won't type it. We'll just write any. You shouldn't do that. It's better to actually type it properly. And really, it's best not to write it like that at all. We'll write post equal await get one post. And from the context, we can extract params and the ID. Also, let's log our context to the console so we can understand what it is. And we'll proceed in exactly the same way as with get server-side props. Here we simply specify an object props, and then we specify the post here. All right, now we need to receive this post, and we'll also destructure the post. Here we'll have an interface for props type. We'll define our post, type it as prop post, specify post type, specify post type. All right, now if we we're getting some kind of error here. Let's just call it post page. Also, in order for getStaticProps to work, the getStaticPaths function is required. It's exactly what we need so that we can render dynamic pages, which will be converted into HTML pages. For example, we'll have 1 HTML, 2 HTML, and so on. We'll demonstrate this right now as well. Let's write an export with a getStaticPaths function. This is the method that allows us to pre-render pages dynamically. We'll see exactly how this works in a moment. In order to pre-render, we need to fetch all the posts, meaning we'll retrieve all the posts. a wait get all post. You'll see in a moment why we need to do all this. We return an object, but this time with specific fields. Paths, meaning the routes that we will render. Here we'll specify our posts and use map to iterate over each item, returning an object with params ID, where ID will be equal to the item's ID. All right. And fallback. So fallback is a parameter that tells us whether we'll get an error if this field doesn't exist. All right, now let's save it. We can see in the console that our dynamic parameters are being found in the context, then localization, and with get static paths, we will pre-render our dynamic pages. If we do it this way, let's build, we can see that all our 100 pages are being generated. All right, let's go to next, to the server, to pages, posts, and we can see all our 100 HTML pages. Why do we need this? The point is, when we go to the source, everything is already rendered. It's all statically rendered, and the rendering itself happens as quickly as possible. If we do the same thing as with the main post page, that is server, site, robs, and run npm run build, we've built everything very quickly. Now, if we go into pages, posts, we can see these dynamic parameters. All right. We also need to check how our ESR works, that is incremental generation, when over time we load something so that we can work incrementally. To do this, all we need to do in the static props is to specify as a second parameter besides the props a concept called revalidate. In revalidate, we specify the number of seconds, that is, after what interval our data will be updated. That is, now, since we have placeholder doesn't update dynamically, if something were to change there, after 10 seconds, we would see it reflected on our page. All right. Now, let's say we need to render all of this. Let's render it inside the div, a div, the title, post title. Next, we'll render the body, post body, and then we'll display our ID, but this time from post ID. All right. Now we can see that everything has rendered great. So now we need to implement a feature so that when we click on our post, so here we have a post, and when we click on it, we navigate directly to our post. We can actually do this using our A tag. Let's see how that will look. Here is the item ID. So we'll need to wrap all of this in a div. We've wrapped everything in a div. Now it will look like this. We can see that our links are there. If we click, we can see that it actually starts loading. So it's not really that great. Why should we even trigger a full reload if we can use JS to load only the elements we need into our window? This is the question the Next.js team asked themselves, which is why they developed the link component. With it, we can navigate between routes we need without any reload. This is also more optimized than using the native anchor tag. When creating a link in versions prior to 13, you also need to wrap the link component with an anchor tag inside. And if we click on any post, we can see that no reloads occur, but at the same time, we are redirected to the post we need. And this is also more optimized than using our native anchor tag. Now, let's move on to the post and, for example, render an image. So the post has an ID, and we will use this ID to fetch a completely random image and render it. We could also do this using our native img tag, but that's not optimized. That is, if we want to somehow optimize the image, for example, not render it when it's not in view, add loaders, overlays, and so on, it would be quite problematic to do all that. With Next, it's all a bit simpler. We just write our image using the image tag in our image component, and it's much more convenient to work with. It's also more optimized. We write our image tag, and we need to import it from Next image. Next, we need to pass the src. In src, we'll have a route like this. That is, using the ID from our query, we'll get a completely random image. Next, we absolutely have to specify the alt attribute. For example, let's say we have random image. All right. And here we'll set the width, which is also required, as well as the height, which is also required. And we can also specify the quality parameter, which determines how high the image quality will be. By using our image component, we can optimize our images much more effectively than if we were just using the native img tag. We can see that our image is loading. Let's say we set the quality to 100. We can see that the resolution has changed. It's become much better. For example, let's say we need to go back to all our posts. We can also do this quite easily. In use router, we have parameters that are responsible for this. That is, we can see that we have push, replace, reload, back, forward, and so on. We can reload our posts. We can navigate while saving to our history, without saving to our history, with loading, with reloading, and so on. but we'll make everything much simpler. We'll just do a back action, that is, go back, and simply return to the previous page. Let's write a button that will be responsible for going back. We'll add an on-click handler and go back. Great. Now let's implement our go back. We can see that we're indeed going back. To write a handler for our 404 page, to do this, first navigate to the pages directory within your project. Next, create a new file named 404tsx, which will be responsible for handling any request to pages that do not exist. In this file, you should then export a default function called notFound, which will define and render the content that users see when they land on a non-existent page. And here we just write a return with a div saying not found. Save it, go back, and refresh the page. We can see that not found has now been replaced with our own implementation. To set meta tags for our paginy page, whether it's dynamic or regular, we need to use the head tag. And inside the head tag, we can specify our titles and anything else we want. So our next head, here we can set the title and post title. All right, let's also set it for all posts and specify the title. Let's go in it's not visible here, but let's do it like this. We can see that here we have up posts. We go to the page and see that our title is displayed here as expected. Next, I mentioned that we have the ability to create a small backend right in Next. To do this, in the pages folder, we need to create an AP directory. After that, our routing is also handled by the file name. Let's create a posts a.ts file. For this, we need to export a default function for post, accept request and response, and type them. In the API, we import Next.API request and Next.API response, type them, and also specify Next.API response. Here, we haven't specified the function. Next, we'll define the type for our post. Let's say, for example, it will only have a title, and we can send a response, status 200. So just like usual, our server, we create a JSON object and send it. For example, the title will be hello, and the body will be world. Here, we can set up some kind of communication with Prisma, return posts, and also interact within our application. To access our API, we go to our API post. We can see that we are indeed returning our posts. Here, I just have an extension installed that displays our JSONs in a more user-friendly way. All right, now Next.js version 13 has been released, and we're going to take a look at it right now. Let's switch to Next 13. We can see that, first of all, it shows us how to install it. Next, it shows us the changes. The main change is essentially the update to our routing system. Previously, as we saw, we needed to have a pages folder, but now we have an app folder, and inside the app folder, the structure is organized. If, for example, we have a dashboard, the main file is JS, then we'll have layout.js. This is the file that allows us to create a layout, as well as handle errors. In other words, that's where we can handle errors, and loading is where we can handle various loaders. Next, we have server components. All our components are server components. What does that mean? If we interact with our component and want to use something like useState, we won't be able to do that because all useStates and other dynamic features only work in client components. To do this, you need to specify something like useClient at the beginning of the component, which allows us to interact with our hooks. All components without this directive will be server components. So why do we even need server components? They are needed so that we can fetch data on the server side. Next, we have streaming. Streaming is when we dynamically load all our data, for example. As we scroll through our page, our components are loaded when we need them. This also has a positive effect on performance. Next is data fetching. Previously, when we interacted with data fetching to achieve server-side rendering, we used get server-side props, received our data there, passed it to props, and then accessed it here. Now, all of this is simply replaced by our asynchronous functions. We write a getData function where we receive our JSON, and then in the component, we can use a wait to get the data and render it. These data will be available right on the page. TurboPack has appeared, which is, I think, about 300 times more powerful, as it says here, 700 times more powerful than Webpack, and 10 times more powerful than Vite itself. As we know, Vite is much faster than Webpack, significantly faster, but they say that TurboPack is really something, it's 10 times faster than Vite itself. That's really cool and really good. Next, there are some changes in our components. Then regarding fonts, we can now connect different fonts like Google fonts. With roots, we see that if in version 12 you had to specify a, as I mentioned in version 13, you don't have to. You can just specify it like this. All right, now let's take a look at our Next.js version 13 and see how everything works. For this, we need to go into next config.js. Here we'll specify experimental dir, true. We'll create our app folder and then create a post folder. Here we'll create a page file. We need to re-render all of this. So we can see that everything has now changed. Let's go to the post. We can see that everything is rendered. Here we can actually use just our await. We write const post equals await. All right. And display our posts. Item as if item. All right. Now let's move on. We can see that our posts have rendered. If we go to view page source, break the lines, we can see that everything is rendered. To enable incremental generation, we need to specify next revalidate 10. So in our feature, to make it static, we need force cache. And for get server-side props, we need to have cache, no store. Let's set our no store so it won't be saved. All right. But if we have a situation where we want to use use state, let's say we try to use use state, date. Let's try to save it. We can see that this actually resulted in an error. But why? Because this is a server component. That is, all data fetching happens on the server. Accordingly, for this to be a client component and for us to use our dynamic features, we need to specify use client. But at the same time, we lose the ability to use our await get outposts. Now, if we specify it, we'll see that a different error appears. We can see that a different error has appeared. We're getting a promise and we can't render a promise. So in order to work with our posts and load them, we need to use useEffect and fetch the data that way. That's why it's important to separate client components and server components in this way. If we need to specify some dynamic parameter, we need to create another folder called slug inside our posts. This slug folder will indicate that we have a parameter after posts. Here we also create a page, JSX file, and here we export the default page, and then we simply return something just as before. We go to the post and see our hello. So let's write hello world here. This is how Next.js works for us. That's basically why we need it for rendering, optimization, and all that stuff. So subscribe, leave a like, and tell your friends. All the code we've covered will be on GitHub. The link will be attached in the description.